ለመማር ወደ ትምህርት ተቋም መሄድ ግድ አይደለም። ናሽናል አቪዬሽን ኮሌጅ
ራሳችሁን ከኮሮና ቫይረስ ወረርሽኝ እየጠበቃችሁ በቤታችሁ ወይም በተመቻችሁ ቦታ በኢንተርኔት አማካኝነት በኦንላይን ትምህርታችሁን መከታተል ትችላላችሁ።
ካናዳ ከሚገኘው ኢንተርናሽናል ኤር ትራንስፖርት አሶሲዬሽን አያታና ከእንግሊዙ ኢንስቲትዩት ኦፍ ኮመርሻል ማኔጅመንት ICM ጋር በመተባበር የሚሰጡ ትምህርቶችን ተከታትላችሁ በ6 ወር ጊዜ በዓለም አቀፍ ደረጃ ተቀባይነት ያለውን የስልጠና ማስረጃ ባለቤት መሆን ይቻላል።
ልምድ ባላቸው መምህራን እየተማራችሁ ጥያቄና መልስ የክፍል ስራዎች ፈተና መፈተን ክፍል ውስጥ እንዳላችሁት አይነት በኦንላይን ባላችሁበት ቦታ ከናሽናል አቪዬሽን ኮሌጅ
የናሽናል ኤርዌይስ እህት ኩባንያ
Okay, this is mathematics class. Last time we have seen proposition and open proposition, and I shared you the document, and today let's start by doing some exercises that were given for you. If you remember, in proposition I gave you 6 questions. If you remember, find if each of the following sentence is a proposition, and if so, find its truth value. So the first one is 1 plus x equals x for every real number x. So as I told you last time, if a sentence is a proposition, we can assign its truth value. That means whether it is true or false, we can able to assign its truth value. Unless and otherwise, it will not be a proposition. That means if we cannot able to assign the truth value of a given sentence, then it will not be a proposition. Maybe it is an open proposition, or neither proposition nor open proposition. But for this specific example, 1 plus x equals x for every number x, this is a proposition. Why? Because 1 plus every number couldn't give us the number x itself. So this time we can able to assign the truth value, which is false. Since we can able to assign its truth value, which is false, so the sentence given under A is false. Therefore, it is proposition. So you shouldn't be confused that under A there is a variable. Last time, as I told you, if you remember, if there is a variable and if we assign or if we replace individuals in place of the variable to say its truth value or to assign its truth value true or false, and unless we replace individuals in place of x or in place of the variable, we can't able to say the given sentence is proposition. This time it will be open proposition. But for this specific example given under A, without substituting numbers in place of x, we can conclude that its truth value is false, because 1 plus every real number couldn't give us the real number itself. Therefore, it is false, and the conclusion is proposition. The second one, if you saw under your exercise or under your homework, is God bless you. The sentence God bless you. Is it open or simply statement? If you are listening to me, is it proposition or open proposition? God bless you. ይሰማችኋል መቼ? እሺ ዝምታን መርጣችኋል። Anyways, God bless you is neither proposition nor open proposition, because this is a wish or somebody's blessing. Last time I told you that wish, orders, interests determinations couldn't be propositions because we cannot able to assign their truth value. So sentences of such kind are not propositions. Therefore, we are not expected to give their truth value. The third one, C. I wish the area of every circle was equal to pi. This is again a wish. So it cannot be a proposition. Why? By the same reason with that of the previous one. We cannot able to assign its truth value. That means we cannot say the truth value of this one is either true or false. Therefore, this is a wish, hence it couldn't be proposition. And the next one is 3 times x equals x times 3 for every real number x. This is commutative property of multiplication under the set of real numbers. From your earlier grade levels knowledge, it is true that commutative property of multiplication over the set of real number or natural number, whatever the set that we have. Therefore, this sentence, even though that it has a variable x, but 3x is always equal to x times 3. So we don't need to replace individual numbers in place of x to assign its truth value. Hence, without assigning or without replacing numbers in place of x, we can able to say the truth value of this one is true. Therefore, this sentence is a proposition and its truth value is true. The reason is it is possible to talk about commutative property of multiplication on the set of real numbers. So this proposition and its truth value is true. E, I am determined to get a grade of A in Maths 101. This is determination. This is one's wish to get a grade of A in this course. So we cannot assign its truth value true or false. Hence, it is not proposition. If it is not proposition, as I told you earlier, we will not be expected to say true or false. Therefore, it is not proposition. Okay, F, A plus B times C, A plus B times C. Let me explain this in the whiteboard. A plus B times C is equal to A plus B times A plus C. Let me tie that to corner. A plus B times C equals A plus B times distributive property of addition over multiplication. In our earlier grade level course, there is no distribution property of multiplication, addition over multiplication. It is true that distributive property holds true multiplication over addition. But this one is distributive property of addition over multiplication. So of course there are 3 variables A, B, and C, but without replacing real individuals on the places of A, B, and C, we can conclude that its truth value is false. Its truth value is false because there is no property of such kind. That means there is no property of distribution property of addition over multiplication. Rather, multiplication over addition. So this sentence is proposition and its truth value is false. Its truth value is false. Okay, the next one is exercise on the 5 logical connectives. The 5 logical connectives. They are negation, conjunction, disjunction, implication, and by-implication. We have discussed the detailed rules of these 5 logical connectives. Today, let us discuss on 4 exercises. The first one is question number 1. Question number 1. If negation of P implies R is false. If negation of P implies R is false, and P by implies Q. P by implies Q. And P by implies Q. This one is better. So P by implies Q is true. So we have 2 statements. The truth value of the first one, negation of P implies R, is false, and this is by implication, and the second one is P by implies Q is true. Then which of the following is true? We have 4 alternative choices. The first one, A, P or negation of Q and R. Choice B. Choice B, negation of P and Q implies R. Negation of P and Q implies R. Choice C, negation of P implies Q or R. And finally, choice D, P by implies negation of Q or R. This is Q, negation of Q or R. The question is, which of the following is true? Which one is true? Let us start from the hypothesis of this statement. Negation of P implies R is false whenever the first one true and the second one false. This is the only option that we have. Implication will be false if the first one is true and the second one is false. So R is known to be false and P is known to be false, because negation of P is true means P is false. So from this, P is false, R is again false. From the first given, we can able to conclude these two. And from the second one, P by implies, this is by implication, okay? P by implies Q is true. From the previous one, P is known to be false. So the only option for Q is false. Why? Because this by implication is given to be true. If the first one is false, Q would never be true. Why? If it is true, false by implies true will not be true. So to make it true, since P is false, Q must be false. Last time we have discussed that in case of by implication, if both propositions are of the same kind, we will get the truth value of the by implication will be true. Unless and otherwise, that means if they are mixed or if they are not of the same kind, it will be false. But this time it is true. And the first one is known to be false from the first given condition. Therefore, Q must be false. So the three propositions are already known to be false. P false, R false, Q false, for only this specific example. Now, having the truth values of the three propositions, let us answer four of them one by one. A, P is false, or negation of Q means negation of false, which is true, and R is known to be already false. Therefore, this is equivalent to false, or true and false is already false, because in case of conjunction, if there is one false, it will be false. Now we are in a position to answer the final step. So we are in the last final step. False or false will be false. Therefore, choice A's truth value is already false. Now let's proceed to the second choice. It's negation of P. Negation of P means negation of false. Negation of false is already true. Okay? Negation of false is already true. And under bracket, we have Q implies R. Q implies R means false implies false. As you know, false implies false is already true. In case of implication, false, if it begins with false, it's already true. Therefore, false implies false is already true. So this is equivalent with the first one is true and the second one is again true. So it will be true. So the truth value of choice B is already true. What about C? Negation of P. P is already false. Negation of false is already true. Okay. Implies Q or R. Q or R means Q is false, R is false. So false or false means it's already false. So this is equivalently means that true implies false, because false or false is false, true implies false. As you know, an implication that begins with true and ends with false is already false. This is false. Okay, finally D. Finally D, P is false, by implies negation of Q. Q is already false, negation of false is true, under bracket, or false, because R is already false. So this one is true, this one is false. In case of disjunction, if there is one true, the answer of the disjunction will be true. Therefore, the one inside the bracket is already true. This one is false. So false by implies true. False by implies true. In case of by implication, if they are not of the same kind, so the answer is always false. So look at the truth value of four of the choices. The first one is false, the second one is true, the third one is false, the fourth one is false. Therefore, the answer for the first question is B. So, something that you can conclude from question number one is that to determine the truth value of the given four choices, first you or we have to get the truth value of individual propositions. Individual propositions. That means the truth value of P, the truth value of Q, and the truth value of R. How can we get the truth value of each of these propositions? From the given circumstance. That means from the hypothesis case. The hypothesis given that this negation of P implies R is false, it is given. And the second given is P by implies Q is true. So from these two cases, we should have to go to the 5 logical connective rules. In case of the rule of implication, implication will be false if the first one is true and the second one is false. This is from the rule. And in case of by implication, if one is already determined, because negation of P is true and P is already false, and if this implication is known to be true and P having false, the second by implications left-hand side proposition must have a truth value false. So having the truth value of the 3 propositions, it is very easy to determine the truth value of each of the 4 choices. This is the solution for question number 1. Now let us go to the second question. ይዛችሁታል? ወደ ሌላ ከመሄዴ በፊት ይታያል ግን የጻፍኩት ነገር እስኪ ድምጽ ስጡ። ይታያል?
ይታያል።
እየጻፋችሁ ነው? ይታያል? ኦኬ። የሚታይ ከሆነ ወደ ሁለተኛው ጥያቄ ልለፍ። Okay, the second question. Again, question number 2. The second question, if negation of P or Q, negation of P or Q implies R and negation of R. Is true. This one is given to be true. Let me read it. Negation of P or Q implies R and negation of itself, negation of R, is given to be true, okay? This one is true. Then again, it's choice question. It says, which of the following is necessarily true? Which of the following is necessarily true? I'm going to give you the 4 alternatives. But before that, what is the hypothesis of this question? This complex or compound proposition is given to be true. Then which of the following is necessarily true? Which one is necessarily true? Necessarily true. Okay. Choice A. Choice A. R implies Q. Choice B. Q implies P. Q implies P. And R. And choice C, P and negation of R. And choice D, Q and R, Q and R, then implies P. Okay? It's similar with that of the previous question number 1, because we don't have the truth value of the 3 propositions P, Q, and R at hand. But we can able to have their truth value from the hypothesis of the given question. The hypothesis is negation of P and Q implies R and negation of R is given to be true. So please look at the one which is found at the right hand side of the given complex proposition. This one, R and negation of R. This is our solution. Let us begin with that. R and negation of R is always false. Always false. How do I know that? Because the logical operator or the logical connective is conjunction. the connection of a proposition with its negation connected by conjunction is always false. Let me verify this one. Let R be true. Its negation will be false. So true and false will be false. What about if R is false? If this is false, its negation will be true. False and true will be false again. So whatever R is, the truth value of this one must be false. So this one is already false. The one which is found at the right hand side is known or verified to be false. So the first one must be false. Why I'm saying this one? Because in case of implication, the total result or the total truth value of the implication to be true, and if the second one is false, the first one must be false. If it is wrongly said to be true, it will be true implies false, so that it will contradict with the given condition. But if the first one is false and the second one already verified to be false, false implies false will be true. This is the only option that we have. The second one false, the first one never be true, but it is false. Therefore, negation of P or Q is surely false. This one is false. Now let us go to the rule of disjunction. Sorry. In case of disjunction, the truth value of the disjunction is false if and only if the two component propositions are false. Unless, what does that mean? If either of the two component propositions are true, it will not be false. Rather, it will be true. But now, this specific case, the disjunction is already known to be false. Therefore, the only option that the two components, the truth value is false. This implies, or this indicates, negation of P, the first component, must be false, and the second component proposition, which is Q, is again false. Again false. That means P, negation of P is false, means that P is already true. P is known to be true. So Q as it is false. What about R? R, as I told you earlier, R may have true or false because we have two options, as I told you earlier. If R is true, negation of R will be false, therefore it will be false. If R is false, negation of R will be true, and it will be false. It never violates the given condition. That means this implies this is true, and this one is already false. So R has two options, and R has two options, sometimes false and sometimes true. That I'm not saying that the truth value of R is false and it was at the same time, but it may be true or false, not at the same time. Now, these are the options that we have to answer the truth value of the four options. Now, let us go to the truth value of one by one. The truth value of the four options. The first one, R implies Q. Q is already known to be false. If R is true, true implies false will be false. And if R is false, false implies false will be true. Therefore, it will not be necessarily true, because our question is which one of the following is necessarily true. This is not necessarily true, because sometimes it may be false. In case R is true and Q is already false, fixed to be false, therefore true implies false will be false. Therefore, this has two chances to be true as well as false. Still not at the same time, but sometimes true, sometimes false. It has options. If it is optional, we cannot say necessarily true. So A couldn't be or cannot be the given choice or the best answer. What about B? Q is already false, okay? False implies true is already true. In case of implication, if the implication begins with false, the truth value of the implication is always true. So this one is true. True and this is true, and R has already two options. Therefore, in case of R has truth value false, true and false will be false. So sometimes, of course, true and true, it will be true. So like that of the previous choice A, this has also two options. True or false, but not at the same time. Therefore, we cannot select this as a best answer because we cannot say that the truth value of this complex proposition is necessarily true. Okay, let us go to the third one, C, P and negation of R. The same. Why? P is already true. Negation of R, whenever R is true, its negation will be false. Therefore, since R has two options, true and false, this implies R is equivalently false or true. Therefore, when R is true, its negation will be false. False and true will be false. Okay? Of course, when R is false, its negation is true, and true will be true. But as we did earlier, it has sometimes true or false. What about choice D? We have Q, which is false. False, and it doesn't matter whether R is true or false. If there is one false, the answer for this one is already false, without any option. Because Q is already false, and R has two options, true or false. So false and true is false. False and false is already false. So we can conclude that the truth value of this, the one inside the bracket, is already false. So false implies true is already, this is false, implies this one is already true. So in case of implication, if the implication begins with false, it's already true. So without option, okay? Of course, R has option, but it doesn't matter whether R is true or false, since there is one false over here, and since the logical operator is conjunction, so the truth value of the complex proposition, the one inside the bracket, is already false. And this one is implication. So false implies true is already true. So without option, this one is necessarily true. Necessarily true. So the answer for the second question is D. Okay, let us go to the third one. Okay, the third one, question number 3. All these questions are already attached. I hope these questions are attached to your email. If there is any problem, we'll discuss later on. Anyway, let me give you the question. Let P, Q, and R are propositions such that P is false, Q is true. Okay, P is known to be false. Okay, this is given to be false, and Q is true. Q is true. P is false, Q is true. Which of the following is false? The question is, which one of the following is, I think it is false, right? Which one of the following is false? Yeah. So this is a question. Let me give you the choice as we did earlier. A, P by implies negation of Q. P by implies negation of Q. Choice B, negation of P or R. Negation of P and, sorry, this one is or R. And choice C, R implies Q. R implies Q. And finally, choice D, R and negation of Q. R and negation of Q. Okay, let us start to discuss. P is known to be false or given to be false. Q is given to be true. But for the time being, we don't know the truth value of R. That means it may be true or false. It may be true or false. Since it is a proposition, it will not be beyond that or other than that. It is either true or false. It has two options, but not at the same time, but sometimes true or sometimes false. But in case of P and Q, already their truth values are fixed. False for P and true for Q. Okay, let's go for each choices. Choice A, P implies negation of Q. You can think over the truth value of these four choices. For A, P is already false. False implies negation of Q, negation of true. Equivalently, false implies false. It doesn't matter whether this one is false or true in case of implication. To say it is true, it is satisfactory to be the first one false, to say true. An implication is true if it begins with false. So we don't need to go to the second proposition's truth value if the first one is known to be false, to say it is true. I'm talking about the implication will be true, or if the first component proposition is false. In case of implication, the answer is already, or the answer is always true. So this one is true. Okay, this one is true. The second one, choice B, negation of P or R. You know that P is already false, so negation of false. Or we don't know the truth value of R, but it doesn't matter. Why? Negation of false is true, or whatever it is. Sometimes true, sometimes false. Look, if the truth value of R is true, true will be true. And if the truth value of R is false, true or false is still true. It doesn't matter. In case of implication, if the truth value of one of the component proposition is true, therefore it is already enough to say that the truth value is true. So the truth value of the second choice is already true. What about the third one? C. The third one, R implies Q. R, we don't know the truth value, sometimes true, sometimes false. But one of them. When I say sometimes true or sometimes false, I'm saying that, or I mean that one of them at a time, but not both at a time, but one of them at a time, implies Q. Q is already known to be true. Look, in case of implication, if the second one is true, it is always the truth value is true. Never be false. If the second one is true, if we don't know the truth value of the first one, so the answer for the implication is true. It's just like that of the previous one. We say in case of implication, if the first component is known to be false, even though we don't know the truth value of the second one, it's already, or we will be in a position to say the answer is true. If the first one is false, in case of implication, if we don't know the truth value of the second one, we can able to conclude that the truth value of the implication is true. Like that of this one, in case of this implication, if the second one is known to be true, if we don't know the truth value of the first one, the truth value of the total implication will be true. These are very important cases in case of implications. Look, if this one is true, false implies true is true. And if it is false, false implies false is still true. What about here? If this one is true, true implies true is clearly true. What about it if it is false? False implies true is true. So once if we fix the second one true, no matter how the first one and the truth value of the total implication is true. This is just like that. So the answer for the third one is true. What about choice D? Choice D. Array is already sometimes true, we say it's sometimes false. It has two alternative truth values and negation of Q. Negation of Q means negation of true. It is false. That means equivalently means that true or false and negation of true is false. The answer for this one is false. I can justify this one. False and false is already false. False and true is false. So no matter the truth value of array is true or false, since the second one is already fixed to be false, so and the logical operator is already conjunction. In case of conjunction, if one of the component propositions truth value is false, therefore we can able to conclude that the truth value of the conjunction is false. We can summarize this one like we did earlier. Here are the two components. They are connected by conjunction operators. If one of the two components is known to be false, and if we don't know the truth value of the second component, it is already known to be false. One is enough. In case of conjunction, one is enough to be false. In case of disjunction, if there are two component propositions, if one is known to be true, and if we don't know, or no matter if we don't know, or no matter whether we know the truth value of the second one or not, but the answer must be true. This one is false. If one is false, in case of conjunction, so we can able to say false. In case of disjunction, if one is known to be true, the answer must be true. So these are very important cases, okay? Okay, of course you are not new for these courses. You are so much familiar with this. So the answer for this one is D, because which one of the following is false, we are asking, and only D is false. The rest of them, as you see earlier, are true. Okay, one more question left. Question number 4. Okay, question number 4. Question number 4. Let me write down question number 4. If negation of still conditional statement, if negation of S or R the by implication symbol is already inverted, not from left to right, rather from right to left. Okay, be careful, this kind of arrow. This one is R, sorry, this is R. P and Q is false. So still is choice question. Which of the following is true? Okay, which one is true? Which one is true? Okay, let me give you the choices one by one. Choice A, R inverted implication symbol S. Choice B, negation of P disjunction, that means or negation of S. Choice C, P and negation of Q, P and negation of Q by implies R, by implies R. And finally, choice D, P and R, P and R, okay? Now, attention, here an implication with inverted arrow is given to be false. This is our given condition. Now, let us rearrange in the formal way of writing solution. The solution in the formal way of writing is that P and Q, this one comes first, implies negation of S or R is given to be false. In case of implication, its truth value will be false for a specific one case. Look, in case of implication, true implies true is true. True implies false is false. This is the only option for the implication to be false. And false implies true is true. And false implies false is true. We have 3 true cases. Only we have one false case. So an implication will be false if the first one true and the second one false. When we say the first one, this one, P and Q. So P and Q will be true, implies the second one will be false. That means negation of S or R will be false. So this time this one is false. So true implies false will be false. So P and Q equivalently means that, or its truth value is true, and negation of S or R will be false. So we come across to the second step. This is the first step, and the second step is this one. From the second step, one can clearly conclude that in case of conjunction, the truth value of the conjunction will be true if the component propositions are true, both true. Unless and otherwise, that means if there is one false, it will never be true. Rather, it will be false. As you can see, true and true is true. True and false is false. False and true is true. And false is, this one is false and false. So we have 3 falses and 1 true. So this one is not true. So the conjunction will be true if both component proportions have the same or identical truth value, which is true. So this time P is true and Q is also true. What about the second one? In case of disjunction will be false if both are false. Because if one of the component proportion has truth value true, it never be false. That means it will be true. So this negation of S, here it is P or true or true is true. True or false is false, true. And false or true is true. And false or false is the only option that we have, which is false. This is the false case. Therefore, negation of S as well as R both have or will have truth value false. So negation of S will be false, R will be false. Now we are in a position to determine the truth value of the 4 propositions. This implies S will be true. Now P, Q, R, S. P has truth value true. Q, that is already true, S is again true, R is false. So we have got the truth value of the four propositions. The four propositions. Now we can go to decide the truth value of the given choices. The first one, A, it is already inverted. Therefore, it will be S implies R. That means false implies true. So choice A, S implies R means false implies true. It will be true. What about choice B? Choice B, negation of P. Negation of P or negation of S. Equivalently means that negation of true is already false, or negation of S is negation of false, which is true. So it will be true. What about C? C, P and negation of Q. P and negation of Q. Then by implies R. Equivalently means that P means already true. So true and negation of true is already false. So by implies R is already true. Okay, by implies. So equivalently, this is true and false is already false. False by implies true. They are not the same kind. For in the case of by implication, the answer will be true if they are of the same kind. Since they are not the same kind, therefore the answer will be false. What about choice D? Choice D, P and R. P and R means that, or it is equivalent. It means that true and R is already true. So it's true. So the only false truth value is found in choice C. So the answer will be C. The answer will be C. So this is the second exercise. Now let me turn, or let me go to take you to slide number, if you have the document, let me take you to slide number 28. Slide number 28 on the PowerPoint presentation that was given last time. Determine whether each of the following compound proposition is a tautology, a contradiction, or neither. Okay? Let us see them one by one. ይሰማችኋል? እስኪ ድምጻችሁን ስጡኝ አንዴ። ይሰማል?
ይሰማል።
Okay. So let us continue. A, question given under A, P implies Q, P implies Q, by implies negation of Q, implies negation of P. Okay, let us do it together. Let us construct the truth table for the given complex or compound propositions. After we have constructed the truth table, we will decide whether the compound proposition is tautology or contradiction or neither of the two. How many propositions are already participated in the formation of this compound proposition? Only two. Therefore, we will have 2 to the power of 2, which is equal to 4 rows. Two propositions, namely P and Q. Two propositions will have, or the table will have 2 to the power of 2, which is equal to 4 rows. But how many number of columns? It depends on the structure of the compound or the complex proposition. Let us start forming the truth table. P, Q, if there is negation or if there are negations, they will take the next columns. Negation of P, negation of Q. And if we have already fulfilled the negations, turn back to the first bracket. So the one inside the bracket should have its own truth value according to its column. And the second bracket, which is negation of Q implies negation of P. So this is the first column, second, third, fourth, fifth, sixth, and final. The combination or the connection of the fifth column and the sixth column by implication will take the last column, okay? So P implies Q, that means this column, under bracket, by implies, and this one, which will be the sixth column, so negation of Q implies negation of P. Now we have 4 rows as we did earlier, or as we have determined or discussed earlier. These are the 4 optional rows. First column, second, third, fourth, fifth, sixth, and finally 6. I mean 7s. So let us fill each alternatives. Now look, here we have true, true, false, false for the first case. And the second column will take true, false, true, false. Even though there was a technical problem last week, but I already mentioned or tried to discuss that these 4 options are not mandatory in their order. The last order may come first, and the third may come second, or any vice versa order, or in any case. But true, true should be one of the 4 alternatives. True, false, one of the 4, and false, true, and false, false. But the orders are not fixed or not messed. In any order, the 4 cases must be put under hand. The next one is negation of P, false, false, true, true. You can fill without waiting for me. And negation of Q means negation of true, false, negation of false, true, false, true. Now, implication among the 5 logical operators. Okay, we have only one false in case the first one true and the second one false. In the other 3 cases, it will be true. It will be true. And the next one is implication of their negations. Of course, the second negation implies the negation of the first one. So from here to here, false implies false, clearly true. True implies false, clearly false. True implies false. I'm beginning with negation of Q, okay? So false implies true is true, and true implies true is true. Okay. Finally, the fifth and the second, the sixth column are combined using the logical connective or the logical operator called by implication. True by implies true is true. False by implies false is true because they are similar. True, true, true. True by implies true, true. So we have got, this is the position, and it has in any case, in any row, 2 truth values. Therefore, for each assignment, we have got 2 truth values. Therefore, the compound proposition is concluded to be true. Therefore, it is tautology. It's tautology. If we have had one false and the remaining are true, it never be tautology, as you know. We will say tautology according to our previous session's topic. We will say tautology for every assignment, for every row of the given complex proposition. We must have to have truth value 2. If one mixed different truth values, that means false, is already mixed, it will be neither tautology nor contradiction. Okay, let me take you to the second one. It is a little bit harder than the previous one. Okay, I hope you have done side by side with that of this. Let me take you to the second one, the second question. First, let me write the question. The second question, or under B, under this parenthesis, we have P and Q or R. Q or R. Then by implies, again, in another parenthesis, we have negation of P and Q. P and Q. Then by disjunction, it's connected with that of the negation of P or R. P or R. So this is the second question. Okay? The second question. Let me rub or clean the previous one. Sorry for the time on stage. Okay, let us start. This is a compound proposition. The bridge connector is by implication. It connects two component compound proposition. What are the components of these compound propositions? The one which is found in the first square parenthesis and the one which is found in the other square parenthesis. So how many propositions are participating in the formation of this big compound proposition? 3. What are they? P, Q, and R. There are 3. So 3 propositions. 3 propositions, namely P, Q, and R. This indicates that 2 to the power of 3, which is equal to 8 rows to construct the true state. Okay? So we will have 8 rows, but the number of columns will be decided according to the formation or the design of the compound proposition. Let us start. Okay? Here, the first one, P, Q, R. If there is any negation of a specific component or specific proposition, we will write. But there is no negation of specific single proposition, but negation of compound, negation of compound. So before we are going to write the negation of the compound, let us first have or take the one or those which are under the brackets. That means Q and R. Q or R. So P and before that Q or R. Here it is P and Q or R. It's already finished. So the one which is found at the left-hand side of the bridge connector called by implication is already done. Let us go to the right-hand side. First, we have P and Q. It will take one column. And the negation of P and Q will take the other column. And then we have P or R. Then its negation will take the other column. Here it is. Finally, this one and this one are connected by this junction. So negation of P and Q, or negation of P or R. So let us say this one as letter proposition A and this one as proposition denoted by letter B. Finally, we have A, this one, by implies B. Therefore, A by implies B will take the final column. Now you can count how many number of columns that we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 columns. 11 columns. So we will have, or we have already decided to have 8 rows. So this will be first row, second row, third, fourth, fifth, sixth, seventh, and finally eighth. ኦኬ አሁንም ከይቅርታ ጋር እስኪ ቴብሉ በደንብ ይታያቸዋል? ከጫፍ እስከ ጫፍ ድምፅ አሰሙኝ አንዳችሁ።
ይታያል ቲቸር።
በጣም
ይታያል።
ኦኬ ይታያል? እሺ አመሰግናለሁ። So let us continue. We have 11 number of columns and we have 8 number of rows. What is our objective? Our objective is to conclude whether this given complex or compound proposition a tautology or contradiction or neither, depending upon the truth value that we are going to assign in the last column, okay? In the last column. So let us start. The first one for P, true, 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 true. 4 truths and 4 falses. For the first one. For the second one, 2 truths and 2 falses. 2 truths and 2 falses. And for the third proposition, 1 true, 1 false type, okay? 1 true, 1 false, 1 true, 1 false, 1 true, 1 false. Look, before we are going to fill the rest of the columns, let us say something here. If the participatory propositions are 4 in number, the number of rows will be to the power of 4 will be 16 rows. This time, the first proposition will take 8 true, 8 false, 8 true, 8 false type. The second proposition will take 4 truths, 4 false, 4 truths, 4 false. And the third proposition will take 2 truths, 2 false, 2 truths, 2 falses. And the final S column will take 2, 1 true, 1 false, 1 true, 1 false type. Okay? It goes like that. It doesn't matter whether the number of propositions are n. Okay? It goes like that. Okay, let us start to fill each of these columns. This is disjunction. And I hope you know the rule of disjunction. So let us fill Q or R. If there is 1 true, so it's already known to be true. True, true, true. Q or R. If both are false, it will be false. Okay, here it is. Okay, just like this. Okay, the next one is P is going to be connected with that of Q or R. Okay, Q or R. Q or R means the fourth column. P means the first column. So first column and fourth column will be connected by the connector conjunction or the so-called end. So true and true, 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 false. If there is 1 false, it will be false, okay? False, 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 false. If you have found any error, you can tell me, okay? Or you can interrupt me, okay? This is letter A, okay? That we are going to discuss, or we'll take it later on. What about in case of end for P and Q? We have 2 truths because both are true. Then the rest of them will be false because if there is 1 false, conjunction will be false. Okay? Negation of this means 2 falses and the rest of will be true. Okay? What about disjunction of P and R? If there is 1 true, it will be true. So this one is true, true. The next one is again true, P or R, again true, true, false, false or true is true, then false, okay, false. The negation of this column means false, 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 true, false, true. Now, this column and this column will be connected by this junction. So false or false is false, still false, true, 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 true. Okay, so this is column of B, column of B. Now, this is A. This column is already denoted by A. This column is denoted by B. So A by implies B. A by implies B. Now true by implies false is, as you know, false. Then again false. Then true. Then false. Then false. False again. False again. False. This one is true, and this one is again true. So true by implies true is true. So if you have any suggestion or question based on this question, you can raise. Of course, you can check, especially the third row, you can check if you have any doubt. That means P and Q or R. Q or R is already true, so true and true is already true. So this one is true. What about in case of B? It says already true. So P and Q is already false. Yes, it is false. Negation of false is already true. P or R is true. Its negation is false. So true or false is already true. So this one is surely true. This one is already true. True by implies true will be true. If the one inside or the one inside the third row is false, since the rest of them are already false, it will be contradiction. But since there is only one true and the others are already false, the conclusion is the compound proposition is neither tautology nor contradiction. Okay. So this is the second question. Now let us go to the third one. Okay. The third question. Let me write the question first. The question first. Question under C. It says negation of P or Q. Sorry, negation of Q. Negation of P or negation of Q by implies P and Q, okay? P and Q. There are only two participating propositions here. So we will have 4 rows, okay? 4 rows. Of course, you can fill here, but let me wait for you for some seconds or a minute, okay? Of course, the last column is not clearly seen. Anyways, this much is enough. The third row true, the others already found to be false, and the conclusion is neither tautology nor contradiction. Now, the next question is since this one was already given as a homework, you may come with solution and you can make the discussion fast. Anyways, the third one, let us see. Here is P, here is Q. We have negation of P, we have negation of Q. We have their connection by disjunction and P and Q. Finally, the fifth column and the sixth column will be connected by implication, okay? Negation of P or negation of Q by implies P and Q, okay? P and Q. So this will be first column, second column, third, fourth, fifth, sixth, enough. Okay, let us fill. Four rows. Here are two truths and two falses. True, false, true, false. Negation of P means two falses down, two truths again down. Negation of Q, false true type. False true type. Now, third and fourth row connected by disjunction. So false or false is false. You know, true, true, true. Clear. P and Q. P and Q will have only one true. The rest will be false. Now, the fifth and the sixth column connected by implication. False by implies true. Since they are not identical, it will be false. This one not identical. In case of by implication, if they are not similar, therefore it will be false. All are false. So for each assignment, that means for each rows, we have got the same truth value, which is false. Therefore, the given compound proposition is contradiction. Contradiction. Okay? It's contradiction. The first one was tautology. The second one was neither tautology nor contradiction. And the third one is, as you can see, it's a contradiction. And we have one more question, but it will be left for you as home task. Here it is, negation of P and negation of Q implies negation of P or Q. At the beginning of the coming class, I will ask you whether this one is tautology or contradiction or neither of them. Okay, this was the given exercise. Okay, now we can continue open propositions and quantifiers. ስጨርሱ ትነግሩኛላችሁ። አሁን ወደ ቦርድ ሳይሆን ፊት ለፊት እንገናኛለን። ዶክመንቱን ሼር አረጋችሁና ትከታተሉኛላችሁ። ስጨርሱ ትጠቁሙኛላችሁ። Let me take you to slide number 29, okay? Slide number 29. Open propositions and quantifiers. I hope you have the idea of open propositions and I already revised what open and simply proposition. So we said propositions are sentences that are assigned their truth value either true or false, but not both at the same time. In case of open propositions, there may be one variable or more than a variable, more than one variable, that becomes a proposition, when individuals are substituted by or substituted for the variables. That means sentences are open propositions unless we substitute individuals in place of the blank space or variables. We cannot be able to say their truth value is true or false. If this is the case, so it will be open proposition. So for open proposition, we expect a variable or blank space. But something that you shouldn't confuse is that, or shouldn't put you under confusion, is that sentences which contain variables may not be open proposition sometimes. For example, a sentence given by x squared is greater than or equal to 0 for all real numbers. Of course, there is a variable, but this is not open proposition. Rather, it is proposition. Why? Because without replacing an individual real number in place of x, we can decide its truth value. We can assign its truth value. X squared for whatever number may replace, or x, the square of every real number is greater than or equal to 0. So it is true. No matter how the sentence becomes x squared is greater than 0. This is false, because the square, it may not be true for every number. If you insert 0, 0 square is already, we know that 0, so it will not be greater than 0. 0 greater than 0 is already false. So having the idea of the actual mathematical knowledge in our mind, we can decide without replacement or with replacement to decide or to assign the truth value of the given sentence. Anyways, a sentence that contains one or more variables and becomes a proposition when individual or entries are substituted by for the variable or for the variables is called an open proposition. Example given there. X is the day before Sunday. As you can see, if you insert Saturday is the day before Sunday, it will be true. And if you insert Monday is the day before Sunday, it will be false. Therefore, if you insert days in place of X, it may be true or false. Unless we insert, we cannot assign its truth value. Therefore, it's based on replacement of individual in place of X or not. Therefore, it is open proposition. Why is a city in Africa? So if you insert a well-known city which is found in Africa, it will be true, like Lagos, Addis Ababa, Khartoum, and so on. If you insert cities which are not in Africa, like London, Buenos Aires, and so on, it will not be true. That means it will be false. So the truth value of question number 2 and question number 1, as well as 3 and 4, will be dependent upon the replacement of the right or the wrong replacements. The same is true for question number 3. X is the president of Y. X is the president of Y. So X is the name of the president and Y is the name of the country. So if you insert right matching, it will be true. And if you insert wrong matching, it will be false. So it's all about the individual replacements. And the same is true for Y. Question number 4, Y is greater than Z. So 2 is greater than 3 will be false. And negative 2 is greater than -5, it will be true. So it's just like that. Okay. The next one is an open propositions notation. Okay. How we are going to symbolize an open proposition is just like that. Say Y is a city in Africa, as we saw earlier. So it can be symbolized by writing R of Y. Just R is the property or the predicate, okay? Y is a variable. So instead of writing Y is a city of in Africa, mathematically it can be symbolized by R of Y. R of Y. So as I told you earlier, capital R is the predicate or the property, and Y is the variable. The variable. Similarly, when two variables are already participating in a single open propositions, like we say earlier, example number 3 and 4, X is the president of Y, or Y is greater than Z, just like that. So this one is how to symbolize a given proposition, which is an open proposition. X is the president of Y, and P, capital P is the predicate, and the X and Y are the variables. So in general, an open proposition is symbolized by using a capital letter, okay? Just like P, just like capital R, and so on. So open proposition is symbolized by capital letter. But simple statements, simple propositions are symbolized by small letters, just like we see earlier on the whiteboard, small p, small q, small r. All these are propositions. But when you come to open propositions, they are usually represented by capital letters P, capital letter Q, capital letter R, and so on. And they are already stand for the predicate, and small x, small y, small z are acting as a variable involved in the given sentence. So just as we said for proposition, we are going to say for open proposition. What is that? It's about compound or complex. Last time we have seen complex or compound proposition. Whenever we have one or more of the logical connectors or logical operators on two or more open propositions, or simply propositions for in case of proposition. So an open proposition is said to be compound or complex proposition. One or more of the 5 logical connectives are connected together with that of or by that of 2 or more open propositions. So the 2 or more open propositions may be P of X, Q of Y, R of X, comma Y, and so on. So these open propositions may be connected by a single logical connective. A single logical connective means by and or disjunction or implication or by implication, or more than one logical connectors. Just example given below. Question number 1, question number 2, question number 3 are complex or compound open propositions. Negation of P of X or R of X, comma Y. How many open propositions are participating here? 2. What and what? Capital P and capital R are the given open propositions. 2 is the minimum number, okay? 2 is the minimum number. And one connector is the minimum number for connecting. 2 open proposition is the minimum, but it can be beyond one logical connector, and it can be beyond 2 open propositions. And in case of question number 2, how many open propositions? 3. What are they? Q, P, and R. How many connectors? 2. What and what? Conjunction and implication. And the same is true for question number 3. 2 open propositions, namely R and Q, are connected by 2 connectors. What and what? Negation and by implication. Negation and by implication. Now, this is the last portion for today's class. Quantifiers. I hope you are not new for quantifiers, as you were not new for logical connectors. Quantifiers are mathematical symbols. Usually they are 2 in number, can be attached before an open proposition to change, or the purpose for the attachment is to change the open proposition to become proposition, okay? Without, of course, substitution, without substituting individuals for the variables, okay? Let's see what they are. We say there are 2 in numbers. Quantifiers are usually categorized under 2 categories or classifications. Existential quantifier, as you can see, its symbol is an inverted letter, capital letter E, and universal quantifier, and which is symbolized as an inverted capital A, an inverted capital A. So the existential quantifier can be used for the phrase there is or there exists. If the variable is x, we can read it as there exists x, or there is an x. There is an individual x, or there exists x, or sometimes for some x, okay? For some x. So there exists for some. All these phrases represent the existential quantifier. The existential quantifier. And the second one is the universal quantifier. Can be used for the phrase for all, for each, for every. Usually, the objective of this specifically the last subtitle is to determine the truth value of the quantified open proposition, okay? The quantified open proposition. Unless you come across to determine the truth value of the quantified open proposition, you are not under the right track, okay? The final goal is to determine the truth value of the quantified open proposition. It must be true or false. We are going to assign truth value of the open propositions without substituting individuals in place of the variables, okay? But how we are going to determine the truth value? Simply by attaching the quantifiers before the open propositions. Let us see the following examples. Consider the following open statements or open propositions. The first one, P of x denoted by x minus 5 equals 7. So don't think over that we are going to replace numbers in place of x, okay? But I'm going to give you some quantifier, either existential or universal, that's going to attach with P of x. And after that, we are going to determine the truth value of the given quantified open proposition. You can see the second one, Q of x squared is greater than or equal to 0, where x is a real number. The first one, x is natural. The second one, x is a real number. Now let us see the examples or the questions. Determine the truth value of each of the following statements. Under A, there exists a natural number for x to satisfy the property given under open proposition P. So you are going to say true or false. If you are successful in searching for an individual natural number, a single individual natural number for x to satisfy the given property under P, can you get that individual? Yes. What is that? 12. 12 is an individual natural number. 12 minus 5 is going to be 7. So the quantified open proposition given under A, its truth value becomes true, because we can able to get a single individual natural number, which is 12. What about B? You can read it as every natural number satisfies the given property under P. Is that every natural number can make it true for P? No. For example, 2. 2 minus 5 cannot be 7. Rather, it is negative 3. So if you can able to come with a single counter example, so you can already say false, because the universal quantifier it becomes or it talks about each individual, okay? For every individual, for each individual, for all individuals under the given set. So every natural number satisfies the given open proposition is false. What is our counter example? Say 2. 2 minus 5 cannot be 7. Rather, it's minus 3. So it's false. What about question given under C? Every real number satisfies the property given under the open proposition Q. Every real number. That means the square of every real number is greater than or equal to 0. Is it true or false? It is true. The square of every real number is greater than or equal to 0. The square of every negative real number is greater than 0. The square of every positive number is greater than 0. And the square of 0 is 0. Since it is greater than or equal to 0, we have two options. Either the square is greater than 0 or equals 0. So the square of every real number is greater than or equal to 0 is, it's true. It's true. Why I'm saying every? Because the given quantifier is already universal. Universal. What about D? D, there exists a real number that satisfies the property given under Q. Oh. It's clearly true. Why? Because we have just said under C, under question number given under C, it satisfies for every real number. But under D, for a single real number, it's above what we want. So given under D, we have got 2. Given under C, we have got 2. Given under B, we have got false. Given under A, we have got 2. So these are the truth values of the 4 examples, okay? Finally, these are the exercise. Determine the truth value of each of the following statements under the given universal set. Actually, the 3 questions have the same universal set, real number universal set. The first question, universal. Second, the first and the third universal. The second is existential. So you should have to come with their truth value for the next class in the coming Tuesday. Next time, after this exercise, we will come across to negation of quantifiers and combination of quantifiers. For today, this much is enough, and thank you for listening.
ልዩነት መፍጠር ዓላማችን ነው። ዓለም አቀፍ ተወዳዳሪ መሆን አለባችሁ። የናሽናል ኤርዌይስ እህት ኩባንያ ናሽናል አቪዬሽን ኮሌጅ ጥራትና ደረጃውን የጠበቀ ስልጠና በመስጠት ብቁ ዜጋ እያፈራን ነው። በፍላይት ኦፕሬሽን፣ በበረራ መስተንግዶ፣ በቲኬቲንግና ሪዘርቬሽን፣ በሆቴልና ቱሪዝም ሙያዎች አሰልጥነን ተወዳዳሪ እናደርጎታለን። ኮሌጃችን ካናዳ ከሚገኘው ኢንተርናሽናል ኤር ትራንስፖርት አሶሲዬሽን አያታና ከእንግሊዙ ICM ጋር በመተባበር ዓለም አቀፍ ዕውቅና ያለው ስልጠና እየሰጠ ይገኛል። በፍላይት ኦፕሬሽን በበረራ መስተንግዶ የምንሰጣቸው ስልጠና ከኢትዮጵያ ሲቪል አቪዬሽን ባለስልጣን ሙሉ ዕውቅና አለው። አድራሻ ከጎላጉል ታወር 22 አደባባይ ወደ ሾላ በሚወስደው መንገድ ላይ የናሽናል ኤርዌይስ እህት ኩባንያ ናሽናል አቪዬሽን ኮሌጅ ህልሞን